This is Algebra 1, Term 3, Lesson 8. Today we'll look at some exponential applications, primarily banking questions, but also a fun tennis ball activity in Desmos. So let's start with the GeoGebra exploration. So first, students will go to Slides and click on this link to go to GeoGebra, and then they're going to basically answer the questions that are on this slide using this app. So when they go in, they're going to see an exponential function, and they're supposed to slide, and it will produce slope triangles. They will need to get a screenshot of this function. They'll also do a linear function. And same thing, they're going to slide this. Now this one, if they want to move it around, they certainly can. But I would probably go with a positive slope just so it's easier to compare the two. But they'll take a picture of this one as well. And they will put this one on their slide. And once they get back to their slide with their two screenshots, they'll answer some questions. What is the same and what is different? And then there's two statements. I want them to try to explain what these mean in their own words. Linear functions grow by equal differences over equal intervals, and exponential functions grow by equal factors over equal intervals. And I've also included a few extra questions to kind of guide them in answering those two questions. Those are in the show notes in their slides, so those hopefully will help them come up with a way to articulate the differences between our linear and our exponential functions. Now this first task is very standard. It is just a simple interest situation. You're depositing $500, 5% simple interest. You may need to remind kids how do we calculate 5%? 5 over 100, 0.05. So any of that you need to talk about as a class, this would be the time. And then they're going to create a function, and we're going to call this function A. So A of x equals, create a table, graph, and equation. So most of these kids are going to go out to Desmos, which is great, and do that and screenshot it and put it on this slide. Now when they get to this slide, I've given them a little head start to get the pattern started. I used to spend a lot of time having them figure out the growth factor first. And to be honest, the return on the investment was just not there. I was giving them a lot of time to do it, and it was just like they don't know what they're supposed to be seeing. They don't understand what they're seeing. So I just go ahead and give them a growth factor here. I give them the process so they can kind of see what's happening, and then I go have them find it. So I've just found it works so much better that way, and they really do kind of see what's happening a little quicker and aren't quite as frustrated, because it was a little frustrating starting with them figuring out the growth factor, especially on these banking questions. Sometimes it's hard to see what it is because the ratios aren't exactly the same because they're rounded off, and that just makes it challenging. Anyway, I got them started. I want them to continue the pattern in the table all the way to row 4, or row 5 actually, year 4, and then use that to generate their equation. This does have repeated multiplication, so hopefully they know that means an exponent's involved here. We've done this in our last lesson, so this should help them. The last lesson should help them make sense of this. Now here's the thing. What does 1.05 represent? Since we are paying 5% interest, why is 1.05 the number in our pattern here? So help them make sense of that. Let's have some conversation. What percent is this, and why do we use this percentage and not 5% that's given? I've given you some extensive show notes for teachers to help you with this conversation, but this is a critical conversation to have, so let's be sure we have it. So in their notes, I asked them directly, what is 1.05 as a percentage? And hopefully this is giving them a pretty solid understanding of what this exponential growth here is looking like. Now we have another bank account. So this time the balances are not the same as they were in the prior table. And here's where I have them actually figure out their growth factor. How is this changing? Are we adding something? Are we multiplying something? And how can you determine that? So I'm going to leave this with them. I would give them plenty of time without talking too much initially. And then after they've filled out a lot of this, then let's go back and maybe, they could go to the boards with these too. These would be good to put up in front of the class so that the kids are seeing each other's work and making sense of what's happening here. It's a good way to offer support for kids as they're working through things initially, is board work. All right, a third bank account. This time they're given an equation, and this time I'm asking them what's the same, what's different, what was the starting balance, what was the interest rate, what is the multiplier. We also call that a common ratio or growth factor. Now that's it for the slides. We are going to move out now to the next task, which is Fry's Bank, and this is a classic 3-act task from Dan Meyer. So I'll take you to his site. Okay, we're at Dan Meyer's Fry's Bank site. Now this is not a video, it's just a picture, so you will download the video. So if you click here, it'll download it. You'll play the video, and then you will answer some questions. I asked them to make their initial guess and type it on that first slide. You of course you could just dump the slides all together. The slides are optional anytime you do these 3-act tasks, but I usually have kids record everything in slides so that I have one place to go to see what they're doing with these types of tasks.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents.
All right.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $.
So once they've watched the video, they're going to make their initial guess, and then they're going to work with their team on the remainder of the task. Since you have just completed some exponential banking questions, hopefully that will give them some ideas of how to tackle this, maybe with a table. Maybe they could go straight to an equation. But they do need to create something that shows how this is growing over time, and then what would be the balance in the account. The next activity is Game, Set, Flat, and that is a Desmos Classroom activity. So these first couple of slides are introducing students to good tennis balls and bad tennis balls. That means kids that don't know tennis can still figure out the difference between the two types. But their goal is to figure out which one's bouncing the way you would expect. They do have to do this 4 times, so it can get a little frustrating for some students. All right, once they've done all 4, they're going to create any tennis ball they want, including things that make no sense, like this one. Yeah, this would be a very unpredictable tennis ball. And then tell how you know that it's bad, and then so forth. It's giving you these numbers on this slide, and they're going to tell you some information about tennis balls. And you're also going to use different models to model your tennis ball. All right, now this one I think is one of the tennis balls. I didn't make a prediction about it. Graph it to see. And on this one, they're going to have to figure out the initial and the growth factor. So the growth factor is actually small because it's not growing at all. It's actually decaying. You might want to introduce that term here, but I do introduce it in the next assignment. So it's kind of up to you if you want to get into growth decay at this point. But it is decreasing, and that's important to note. You're not going to multiply by a number greater than 1. You're going to multiply by a number less than 1 to make it decrease. And then keep going. And then finally, there is a slide in here that gives them the percentages that they're supposed to be using. So I would pace your students as you go through the assignment so that they're not jumping ahead and getting those percentages. We do want them to try to calculate these themselves. So this activity should take about half your class period. And if that's true, it would take you about a day and a half to get through this lesson. So that concludes our linear versus exponential lesson. Y'all have a great day.